In this part, as I mentioned before, we're going to evaluate expression involving double angle identities. So our first example, tangent theta equal to negative 4/3, where the angle is between 5 pi over 2 and 3 pi. So again, the angle theta is between 5 pi over 2 and 3 pi. Now if I were to take 2 pi from each side, the equivalent would be pi over 2 and pi. So that it means it's in quadrant 2. So how does that information help us? Alright, since the angle is in quadrant 2, that means what I referred to in the previous section is the signs of x and y. In quadrant 2, x is negative and y is positive. That will help you determine the sign given your values. So let's go with the given value, tangent theta equals to negative 4/3. Now bear in mind, I'm not going to be using tangent of x because, and you'll see why, we're going to refer back to 4.1, the definition of tangent. So tangent theta, so the definition I'm referring to is the one that's using x and y's. So for tangent theta, the definition is y over x, which is supposed to equal to negative 4/3. So using this given information, since the angle is in quadrant 2, x is negative, y is positive, therefore x is equal to negative 3 and y is equal to positive 4. Alright, once we establish that, next we have to find cosine of 2 theta. Now, one of the identities you need to find cosine and the other one you have to find sine, regardless. So if you were given tangent and you were to say required to find either sine or cosine, and using the definition from 4.1 using x and y, we need to find the r value. Tangent theta, the definition, it doesn't give you an r value, it only gives you y and x. But sine and cosine requires you need to find the r value. So the formula ties into this: x squared plus y squared equal r squared. And if I'm trying to get r by itself, it would be r equal the square root of x squared plus y squared. So again, these two ties in with each other. Alright, so I'm going to use this one. So r is equal to x squared, so negative 3. And again, as I mentioned many times, when you plug in, you always include parentheses, plus my y squared, 4, so r is equal to the square root of negative 3 squared plus 4 squared. So negative 3 squared will be a positive 9, 4 squared will be a positive 16, 9 plus 16 will be 25. And then the square root of 25 is 5. Now here, I don't have to worry about the plus and minus because R is always positive. Make sure you remember that. That should be in your notes. R is always positive. Alright, so I'm going to write the R value up here. R equals 5. Alright, we got X, Y, and R. And I think we pretty much have everything what we need in order to find cosine 2 theta. Alright, so what I'm going to do is I'm going to erase to make more room. Now, to find cosine 2 theta, I'm going to use the first identity, which is cosine squared theta minus sine squared theta. Now, again, I mentioned I'm not using x for my theta because we're using the definition from 4.1 where it uses x, y, and r. So since there's an x being used, I'm going to use theta to tell the difference. So that way you won't get confused when you're working with double angles. Now cosine 2 theta equal to cosine squared theta minus sine squared theta. So that basically means if I'm using the definition from 4.1, cosine squared theta, the definition will be x over r squared minus, and then the definition for sine will be y over r, and since it's square, this will be square. Alright, now I'm just going to simply plug in my x, my y, and my r. My x, negative 3, over my r, which is 5, square, minus my y is my 4, my r is again 5, also square. Alright, so negative 3 over 5 squared, that means negative 3, 5 times negative 3, 5. That is going to be a positive 9 over 25. And then minus. Now 4 over 5 squared, it means 4 over 5 times 4 over 5, which will become 16 over 25. And then I'm just going to simply do 9 over 25 minus 16 over 25, which will be negative 7 over 25. So therefore, cosine of 2 theta is equal to negative 7 over 25. And that right there is our final answer. So in review, we start using the definition from 4.1, using tangent definition, y over x, and then the definition of cosine was x over r, definition for sine was y over r. So that means we are not done from chapter 4. And bear in mind, this information that's given so the one I just underlined, you have to use that to determine the true value of x and y, or x and y, because you don't know if x is going to be positive or negative, and you don't know if y is going to be positive or negative. So just like on your previous test, when you're given a secondary information, you have to use it to help you find the correct answer. If you don't, then you're going to get the incorrect answer, and if this was on a test, you will lose partial credit. So bear in mind, if the secondary information is given, you have to use it. Now here, it doesn't tie into the unit circle that you normally know from 0 to 2 pi. What I did was I took 2 pi from each side. So 3 pi minus 2 pi will be pi. 5 pi over 2 minus 2 pi, of course, with fraction, became pi over 2. So, pi over 2 and pi, that's quadrant 2. That helps me determine x and y is positive or negative. So again, it's important you have to use that information if you are to get the correct answer. In our second example, we have sine theta equal to negative square root of 3 over 2, where it's 3 pi over 2 less than or equal to theta, less than or equal, well, less than actually, less than 2 pi. So that means that the angle is between 3 pi over 2 and 2 pi. So that means 3 pi over 2, that's 270 degrees. And 2 pi is 360. So it means it's in quadrant 4. So in quadrant 4, x is positive and y is negative. Alright? So again, we must use that information to find the correct answer when we're working this out. Now, sine theta is equal to negative square root of 3 over 2. So let's review sine theta equal to negative square root of 3 over 2. And the definition from 4.1 is y over r. So, therefore, y is negative square root of 3 and r is 2. Now again, r is always positive, so it's safe for me to say r is 2 and y is negative square root of 3 over, negative square root of 3. So, now the question is asking you to find cosine of 2 theta. So let me write down the question. Find cosine of 2 theta. So, in order to use an identity for cosine of 2 theta, we do need to know our x. We know our y and we know our r. So, with that in mind, we're going to find the x value. So using this equation from 4.1, x squared plus y squared equal to r squared. So I'm just going to plug in y and r. My y is negative square root of 3, so negative square root of 3, include the parenthesis, equal to 2 squared. Alright, so when I'm working this out, x squared stays the same. Negative square root of 3 squared, it will be a positive square root of 9 equal to 2 squared, which will be 4. And then rewrite it, simplify the square root of 9, which will be 3, equal to 4. Alright, so you're going to get x squared plus 3 equals to 4 after plugging in negative square root of 3 and 2 and then simplifying the squares. Next, I'm going to subtract 3 on both sides. So I'm going to get x squared equal to 4 minus 3, which is 1. Alright, and I'm going to write over here x squared equal to 1. Next, I'm going to square root both sides because I want to just get x. So x squared equal to positive or negative 1. Now, again, 1 is a perfect square, so the square root of 1 is 1. So again, I meant to say x equals positive negative 1. Now, using this information, x is positive, so therefore x will simply equal to 1. So we can ignore the negative because we're using this information since the angle is in quadrant 4. So I'm going to write x equal to 1. Alright, so now we got all the necessary information. Y equals negative square root of 3, R is equal to 2, X equal to 1. Alright, so I'm going to erase all this to make more room. Alright, so for cosine of 2 theta, what I'm going to do, I'm going to use the second identity for cosine 2 theta, which is 2 cosine square theta minus 1. Alright, so the definition of cosine is x over r square minus 1. So now I'm going to plug in my x value and my r value. 1 over 2 square minus 1. Now, I'm going to use PEMDAS, so nothing to worry about parentheses. We got one number. So exponent, so 1/2 square, it'll become 1/4. Alright, so then I'm going to move over here for more room. So once I'm finished with that, with the exponents, then the only thing I'm worried about is the number outside of parentheses, so I'm going to multiply to the top. So that's going to be 2 over 4 minus 1. Since we have a fraction with a whole number, simply it's going to be 2 over 4 minus 4 over 4. 2 over 4 minus 4 over 4 will simply become negative 2 over 4, which can simplify into negative 1/2. So, cosine of 2 theta for this example will be negative 1/2. And that will be our final answer. So as I was saying, we need to use this secondary information, 2 pi over 3 pi over 2 less than or equal to theta less than 2 pi, meaning it's in quadrant 4, to determine our true value for x and y. So in this case, x has to be positive, y has to be negative. That will help out to get the correct information so that we can get the correct answer. Now, in the first example, we use a different identity for cosine 2 theta. In this example, I use the second identity for cosine 2 theta. Now, as I said in the previous video, there's 3 identities for cosine 2 theta, but you are free to use any of them, but you are to determine, is up to you, basically, to determine which one is best to use, which one would make your work easy after you are given the problem, and after you analyze, it's like which of the 3 can you use to help you work it out. For me, I use any, so I did an example of the first one and the second one to see how it works.